All right, everyone that's in here, if you can locate your chat box, let me know, can you hear me? Awesome, thank you. All right, so I'm gonna give it another minute just to allow people to roll in here a little bit more. But if you guys are able to see the webinar pretty well and hear me, that's good. If you do have any technical glitches, 9 times out of 10, the best thing to do is to just go in, exit the meeting, and then come right back in. Hopefully that'll do it. And you guys have located your chat boxes throughout this webinar. If you have any questions, please add your questions into the chat box. At the end, I'm going to open up some time for some Q&A, so I'll definitely be able to answer any of your questions. And if I don't, I will definitely be able to follow up with you. So without further ado, we're going to get started today. And of course, our topic of the day is streams, how they work. And we're going to go through, we have quite a bunch to go through today, but I think that it's all going to come out pretty clear, and we'll have some ideas about what we can do with our streams at the end to improve them as well. So today's agenda, I'm going to start off talking about Pennsylvania and Columbia County streams. Then I'm going to go into a little bit about stream health and impacts on our streams, and the things that we do that affect stream health. I'm going to talk a little bit about watersheds, and then I'm going to go a little in depth with some stream dynamics. And I'm actually going to use what we purchased through the Conservation District. We used DEP Environmental Education funds in addition to our Conservation District educational funds to purchase one of these stream tables that actually serves as a model to demonstrate streams. And you can add all these different factors and see what would happen in certain scenarios. So it's a really fun tool. I'm happy to be able to use it via Zoom, and hopefully as you see us out and about, as things start getting a little more normal, we'll be able to take this out and you guys can play with this and see how streams work, in person. But for right now, we're going to be doing that via Zoom and online as best as we can. After we talk about watershed dynamics, we're going to talk about what we call best management practices, or BMPs. And those are basically things that you can do on a stream or anywhere, in conservation to improve the landscape. I'm going to talk about a restoration project so you can see one go through the whole from beginning to the end, and we'll have some time for Q&A at the end. So I thought it'd be fun to start off with a little poll here. I'm going to open it up quick. So you guys should be able to see the poll on your screens. So there's 3 questions there. I'll give it about 30 seconds. If you guys can go through there, answer the 3 questions and submit that, and we'll see where everyone's at. The first question is, what watershed do you live in? If you don't know, that's fine. Hopefully by the end of this webinar, you guys will be able to see, where you do live and have a better understanding of that. And also interested in figuring out, what are your primary concerns when it comes to streams, and also how we could best improve our streams. I'm curious to see what you guys are thinking. So if you can take some time to go ahead and answer those questions in there, and I'll give you about 30 seconds and we'll see where everyone's at. We got a couple of I don't knows, which again, perfectly fine. We're gonna be able to answer those questions for you and figure out where you're at in just a couple of slides, no problem. All right, about another 5 seconds. Going, going. Okay, so I'm going to end the poll and you should be able to see the results on your screen. So pretty cool. Sounds like a lot of you guys are out in the Fishing Creek watershed. That makes sense. A large majority of our county is in Fishing Creek. Some of you live down in the Susquehanna River Basin. That's where I'm at. I'm in Mifflinville, and that actually drains right directly into the Susquehanna. I'm interested about your primary stream concerns. Looks like it's all across the board, which is great. Everything, I'm equally interested in and concerned about. So it's good to see everyone is kind of thinking about every avenue there. And also same thing across the board with solutions. I do see one person said that they'd like to see some dredging. That is another topic that I am gonna address in this webinar. So hopefully we can talk about that and see where we're at the end of this. You should be able to X out of that poll if it doesn't X out for you already. All right, so let's get started. So we can't talk about streams unless we talk about, Pennsylvania in particular. So Pennsylvania has 7 major river basins. You don't need to know them all. However, we are located in the light green area there. Let me try to move this out of the way quick. But so that is in the Susquehanna River Basin. So of course that's where we're at, and that drains in the Chesapeake Bay and eventually into the Atlantic Ocean. So we have 86,000 miles of stream, which is quite impressive. It's actually second only to Alaska. So if you look at that map there, every blue line is a stream in Pennsylvania. So we are, coated with water here. And we're also extremely blessed that we have really great quality water throughout the state. Tons of wild trout and stock trout streams, and we even have Class A wild trout streams, which are just the best of the best streams that you can get. And we do have some of them here in Columbia County. So we have some really great resources, really great streams, and definitely something worth protecting and a value for the state. However, it is worth noting that DEP has done some assessments, and the most recent one, they came out with about 30% of Pennsylvania has impaired streams. So that means that it is difficult to support aquatic life and pollution and whatnot. The number one pollutant in Pennsylvania is sedimentation from erosion. We're all, especially in Columbia County, very familiar with that kind of stuff. But that is our number one pollutant, as well as abandoned mines, which is more common. You might find in somewhere like Catawissa, and also runoff from storms from agricultural areas and also urban areas. So we'll get into that a little bit more as well. So Columbia County, here's a graphic that I made a while back. All of the blue lines are, supporting aquatic life. They're the good streams. Anything in red is an impaired stream. Again, that's listed by the Pennsylvania Department of Environmental Protection. And again, that means that it's minimal aquatic life or it can't support aquatic life. So we have 791 stream miles, so that's a pretty decent amount. And like I said, we have a couple of Class A trout streams throughout the county that are just a great resource that we have, really high quality. It's definitely worth protecting and conserving. And we have a bunch of different watersheds. We have such a mountainous region. We have a lot of different drainage areas throughout our county. So, if you can look at that map and find, approximately where you're at, what township you're at, that corresponding color will tell you which watershed that you live in. So for those that didn't know which watershed they live in, hopefully this map will be able to give you a better idea. But of course, I cannot talk about Columbia County with addressing some of the impairments that we have. About a quarter of our county is listed as impaired, and those are primarily from agricultural runoff, as well as urban and developed area runoff, and some other factors. When we talk about what impairs water quality in streams, a lot of times you'll hear us talk about nitrogen and phosphorus, and those are typically coming out of excess use of fertilizers or manure in the landscape, again, from those runoff scenarios in a precipitation event. And there's also some natural sources that exist naturally in the soil. However, sometimes we overuse fertilizers. So that's a large source of some of these impairments, as well as erosion and sedimentation from stream banks and the instabilities and in the adjustments of the stream, which we will talk about in this webinar. So kind of going along the lines of stream health, I think it's really important to note that there's a very clear correlation between the health of a stream and the land use around it, specifically the impervious areas that are around it. So when I say impervious, that just means that the water is not able to infiltrate into the soil as it normally would. So that is going to end up running off of surfaces like a sidewalk or driveways, even turf grass. With our compacted soils and turf grass, we pool water and it runs off the surface as opposed to ending up in our soil. So when that happens, that water has to go somewhere. It typically ends up, in a stream. We might get a flash flooding event if we have heavy rains, and you can see all the erosion that happens. Any of that runoff is picking up, whatever's on your lawn or within the community. All of that is going to end up in the stream. So that is going to significantly affect aquatic life. And they are, the indicator for if we have a quality stream or not. They're extremely sensitive species. And if they're not present, then that's a good indicator that something else is going on in that stream. So like I said, water quality is very strongly tied to land use. Here's Columbia County again. 41% of our county is either developed or agricultural. So that means 60% of our county is still mostly forested, which is absolutely great. And that really helps us a lot when it comes to stormwater control. However, if you look at that map there, you can see those areas of agriculture and development are really concentrated. So when you have those concentrated areas, you're gonna get a lot of stormwater runoff running off directly into the Susquehanna or in one of our tributaries. And those land uses that affect runoff and what goes on with our streams includes not just impervious areas, but removing forest cover, developing and building more houses, roadways, rights of ways, and what we do on our fields, like compacted soils, tilling fields and that kind of stuff. There's also a really strong correlation of a lack of vegetation in a landscape is also correlated with water quality as well. So I do want to just note real quick, it's not just the stuff that we're doing today that influences the streams. There have been so many different events in past history that occurs on these streams that really affects what's happening today. So what we're doing today, isn't entirely the problem, although there are things we can improve on. But a lot of the things that we're dealing with are lasting effects from what we've done in the past. And just some examples of those, logging. We are Pennsylvania, we're known as Penn's Woods. However, it was a really big lumber industry and still is today. But in the 1800s, and specifically in 1895, we only had 30% of our forest left. There's photos you can see, like the photo in the top right there, that whole mountains were completely, they're bald because we took off all of those trees in that tree cover. And that, of course, led to a bunch of erosion and other things that affected the streams throughout their landscape. Another important note, especially here in Columbia County, because we are such a rural area, we had a lot of mill dams. So back before we had, energy sources, each home had to develop their own, sources of energy. So a lot of them would live next to a stream, dam it up, and they use that water energy to, mill their grains or just power their home. So actually in 1840, the height of the, mill dam era, there was actually over 130 water-powered mills just in Columbia County. And the big caveat with that is that when you have these mills on such small streams, what happens is over time, these mills accumulate really, really fine sediments behind that dam. And as we ended up, getting more energy sources and kind of abandoning the whole dam concept, those mill dams ended up being either completely abandoned or removed. So those actions as well affected the stream. And those legacy sediments, those fine sediments, either ended up going downstream or they build up throughout the landscape. And it makes it really difficult to kind of reestablish that forested area in that stream bank. So those are some other things to think about. And of course, we've messed with streams in terms of building railroads along them and canals, directly through towns, all the development, dredging, channelization we've done in the past. So I just wanted to mention that it's really important to note that, historic uses are also impacting what we're doing and what's happening today. It's not just, what you're doing on your property that's affecting the stream. These are very long time scale type events when we talk about streams. So I want to show you guys an example of that change in our landscape. So this is actually before Interstate 80 was put in here in Columbia County. So you can see that here is Fishing Creek. Now this used to actually be out, it was able to flow in that landscape freely. So this Fishing Creek was more of a braided channel. It was more of a wetland type landscape. And it was able to manage all the energies coming in and out of that stream pretty well and flow throughout the floodplain. Just for reference, here's that old railroad bed and Back Branch Road. And there's that 90-degree turn that you guys might be familiar with. So just to give you guys an example, but this was in 1939. And if I skip ahead here to 1959, you'll notice not much has really changed. The stream has adjusted a little bit, but overall it's pretty stable. It's not moving throughout the floodplain, or it is moving throughout the floodplain pretty freely and not really causing any damages. However, just 10 years later in 1969, 80 was put in. You can see there's a pretty big drastic change in the landscape. So of course 80 is a straight roadway that goes through where that stream was flowing. We completely channelized our stream channel. So now we have, when you're driving on 80, you can see that it's just a straight shot. It's kind of like a fire hose that's coming off of Fishing Creek, and everything kind of blows out as you get a little lower on the interstate there, which is kind of a familiar sight if you're local to the area. We have an abandoned railroad, and of course, Back Branch Road is still there. Interestingly, what happened after we channelized Fishing Creek, the remaining wetlands actually formed what we call the Turkey Hill Oxbow. So that's actually the remainder of the old Fishing Creek water channel there. And it still connects slightly to it through a pipe under the interstate. But I mean, overall, that is really, that's a drastic change within the landscape. That stream is trying to adjust to its small corridor now, and downstream you're going to get a lot more energy, which makes sense because right downstream from that is Bloom Beach and Fernville and Lower Bloomsburg. So that's just an example of historic things that we've done within streams that have lasting major impacts that we might not think today that might be the cause of those things. So let's get back into, talking about watersheds and streams in general. You're going to hear a concept all the time. We're always saying that we all live downstream from someone. What you do on your property is going to affect the person below you and so on. But we can't really talk about that until we define what a watershed is. So a watershed is basically, it's an area of land. Normally it's delineated by like mountains and topography, but it's an area of land kind of like a bathtub that, as you have precipitation, it collects all the water and drains into a single point, which would be a stream or a river. But another thing to note too is that there are different stream orders. And really all you need to know from this and looking at those images is, we have headwater streams and we have streams closer to the mouth of the river. And what's just important to notice is that depending on where you're at within a watershed, there's going to be different characteristics in terms of sediment load and slope that's going to affect the stream. But overall, the stream dynamics are going to be the same. And I just really quick wanted to put up this resource here. This is from the United States Geological Survey. It's called Stream Stats, and you can actually delineate your own watershed from your property. So this is actually a site that we're going to do a project on this summer. But you can actually go into this website, mark a point where your location of interest is, where your house is or your workplace, and you can see your own watershed, every drop of water that flows through your property or next to your property, where is it coming from? So you can really figure out a lot when you look at that, and you can play around with it a little more and really look at your own personal watershed. So I think that's a great tool to be aware of. So streams again, they all generally have these same characteristics, and right here is an ideal, cross section of a stream corridor. You have your main channel, and it has the ability to fill up. And also, if you have an extreme, event of precipitation, you have your flood zone and your flood prone areas that are vegetated. And ideally, you would have, a forested area along your stream, preserved wetlands and floodplain. And you want to keep your house as up on the hill as possible and out of the floodplain. That's extremely important. So unfortunately, a lot of our landscapes don't look exactly like this, but we are working towards that. But it's important to just kind of note that the landscapes kind of have a similar movement throughout, and how we can develop over time. We can really kind of think about these things to do some better development, so we're not, building within our floodplain as often. So I'm going to get into a little bit of technical stuff here. Please bear with me. So streams, I'm not going to get too crazy into it, but streams, it's extremely important to note that they are always moving, changing, and adjusting. They are not a static system by any means. They are always moving, whether we touch them or not. So you have probably noticed that streams tend to form in a meandering type shape, so kind of like a snake throughout the landscape. And that is actually a result of a certain process, which is basically the balancing of erosion and deposition. So the stream is constantly eroding. Erosion is a natural process. It's required and needed for a healthy stream. However, as we add more energy into a system, such as a heavy rain event or melting snow like we have outside right now, as we add more energy and water flows, we're going to get more erosion. And likewise, as we take away that energy, we're going to get more deposition. So those sediments are going to drop out and stay in that stream bed where they fall. But every stream does have actually a natural, sequence that it should have, and it's actually a visual indicator if your stream is healthy or not. But they have these pool, riffle, run sequences, and you'll notice this if you look at a stream. So the stream is actually constantly moving throughout that meander, and in those pool areas, that is a deeper section. Generally in a stream, the deeper the area, the faster the water flow. So that means there's more energy in that pool. So the area is deeper, more energy. That's generally where most of your erosion is going to occur. And then if you notice on the opposite side of the pool, you have all that sediment. We call that a point bar. And that is the lowest flow. So those are the least energy, where all the sediment is dropping out. And you'll notice that, as the flows move from left to right on that image, the coarser materials are heavier, they drop out first, and over time the finer sediments accumulate. So you can see those very easily visually, especially, look at Fishing Creek, for example. Point bars and cut banks are always, always visible and always a concern for us. And in between are those riffle areas, those bigger cobbles that have been settled out, and they're a really important feature, specifically mostly for oxygenation of the stream. And it's really good for aquatic life. Something else to note, again, like I said, streams are always moving. I find this picture really interesting. You can see the old stream channels in this photo on both sides of that stream. So just noting, these things happen over extremely long periods of time, thousands of years. So you're not going to get that drastic of a movement of a stream, within your lifetime. However, with climate change and increasing precipitation events and land use, we will be seeing these rates increase. And the streams are definitely going to adjust and move over time. So again, there's also this concept, which I kind of got into already, called dynamic equilibrium. It's the balancing of two continuing processes, so that erosion, deposition. And we call it degradation or aggradation, right? So you're either lowering the channel, it's eroding, incising a little bit, or maybe it's a grading, it's growing up. So really the stream it's constantly trying to balance its own slope out. Streams don't want to go up and down. Water flows downwards. So it's trying to create a pretty standard stream, slope for itself. And there's a lot of factors that go into, how you tip those scales. But you can see there on that graphic that, if you tip your scales more towards, high energy, high discharge, a more stronger slope, you're going to get more erosive activity, and vice versa. Here are the different parts of a stream, and here's that stream table I had talked to you guys about earlier that we would purchase through the district. So the top area of a stream are called the headwaters, and the bottom area is called the mouth of a stream. So these areas that I mentioned earlier that are kind of the turning point for the meander in the stream are called a cut bank. Again, that is the area with the fastest energy, the most erosive activity. And then quite on the other side are those point bars, again, lowest energy, dropping out materials and building up sediment. So this is called a thalweg, and that's what I was talking about in terms of like where the deepest sections of the stream are. So where the deepest section is, the faster it's flowing, the more energy it has. And that location is called a thalweg, and it moves throughout the channel pretty much constantly. If you have a straight channel, normally it's right in the center of a stream. But again, when you start getting those meanders, it goes from bank to bank, hitting back and forth. And that's what causes that erosion in that deposition. Another important note is the riparian area of a stream. And riparian just means stream side, what's between the land and the stream. But that's an extremely important area. And as you see this stream table work in the next slide, you're going to notice that, you know, if we had trees there and root systems that are stabilizing those riparian areas, we're going to get a lot less erosion. However, in this case, of course, we're not going to have any vegetation established. And similar to riparian areas are floodplains, which is the area that, you know, when that stream flows over its bank, ideally it should have a location it can spread out and infiltrate that excess water into the soils instead of going right back into the stream. So another really, really important feature on the landscape to manage stormwater. So I'm going to run this time lapse, and if you guys want to just kind of make some notes, see if you can identify the different parts of the streams. Now I do change the water flows kind of just to simulate, you know, seasons and whatnot, but you can see that the stream is starting to form. You have some groundwater. Actually, you can think of those as springs or a wetland down below. And now we have our channel starting to form. And start noting it's gonna start creating that meander, that kind of curve in the landscape, and you're gonna see that curve actually start moving. You can see the erosion. You can also see that point bar developing. So lots of activity, again, constantly moving. It's constantly picking up sediment and moving it downstream to adjust to its slope. Here's another example of sediment transport. I just wanted to take a video a little more up close so you can see that water is constantly picking up sediment. It's constantly dropping sediment and eroding, and also dropping it out in more the point bar areas. You can see the sediment flowing with the water there. Bit of a closer example. You can see it slumping off there and moving. You know, where the sediment lands, it's going to readjust the stream and the flows and where that's going. So just an interesting shot to show. So if you guys can locate your chat box real quick, we can do a quick activity. If you guys were going to, you know, build a house on this landscape, where would you build your house? What? Give me a description of where you think would be the best place in this landscape. Any ideas? So in general, away from the screen, right? Yeah, next to the desk, nowhere near the stream. Exactly, outside of the table boundaries. Yeah, so, you know, what we just learned, those streams are moving constantly throughout the landscape. We don't want to keep them in one spot. You know, we don't want to, you know, rock every single side of every stream. We want them to be able to move and adjust. So as we look at landscapes, what I suggest is we should start looking at landscapes and knowing where that stream corridor is, where it's moving, and develop our communities based off of that. Unfortunately, in a lot of cases, we have, houses built currently on floodplains already, and hopefully we can work through that, going forward. But the best place really to think about, how we're interacting, with the streams and flooding and that kind of stuff. You want to keep your house as far away as possible, and most certainly not anywhere near those cut banks that are creating a bunch of erosive forces, or even out on those floodplains, because when it floods, that's where the water is going to go. So just an important note to kind of, think about the landscape, overall. Our properties are so small compared to, everything else that's going around. So really taking that time to analyze our watersheds is important as we develop our community going forward. So I actually want to take some time to kind of flip the script a little bit and talk about, okay, so we understand streams, how they're moving, what they're doing, what they're reacting to, but, how do we identify, what streams need the most help, and also what can we do on those streams? So I want to go into that a little bit more, a little restoration, and talk about this. So, when we look at a stream, some key indicators if that stream needs some improvements is lack of vegetation. Ideally, that would be a forested area, but, shrubs or just, grass is let go wild is really important to make sure that we get those root structures in the soil to stabilize our streams. Of course, habitat for fish and wildlife are really important as well. You'll want to look at a stream and see, is it accessible to the floodplain? Is it able to jump its banks very easily? If you look at this photo right here, that stream is going to take a lot of energy for it to finally get up over onto that bank. And it's probably at that point going to have so much energy, it's just going to continue eroding. So what we would ideally do in that situation is grade those banks back for, a more even slope so that it could very slowly rise up as opposed to just creating more energy. But there's a whole bunch of different, things that we can look at of a stream and identify, does this need some help or not? So there are a couple of guidelines that the Pennsylvania DEP has put out in this graphic here. That's available on their website as well. But it's a guideline to tell you, what you can and can't do in a stream in Pennsylvania. And some require permits, some things don't. Some things are more cost effective and some things aren't. So here's, a list of some things that we can and can't do depending on, requirements for permits and cost. There certainly are some really great cost-effective ways to improve our streams, minimal cost, long-term effects, and we can put structures in them as well. But there are some people that advocate, I mentioned for dredging earlier. So I'm going to actually start with dredging and work my way up that way to explain to you guys why dredging wouldn't be the best idea to improve our streams. So what is dredging? That is when you remove the bottom sediments and debris from a stream bed or any water body. So what that does, like I mentioned earlier, with that dynamic equilibrium concept, that stream is really trying to keep its slope stable. So when we go in and we create, a hole in the stream bed, it's not going to be a very stable stream anymore, and that's going to adjust accordingly. So what you're going to see in this video here, I'm going to go in and take out that point bar that you see. You're immediately going to notice that there's what is called a head cut. So instead of eroding the sides of the banks, it's going to start eroding up the channel. And again, that's kind of a slope maintenance type thing. But that erosion you're going to see at the same time as that head cut, it's immediately going to fill in that hole that we created. So that dredged area is just going to be filled up. And all that excessive energy and sediment is going to end up going downstream. So here's an example of what happens when you dredge. You can see that head cut forming. And all that sediment has filled that hole in there. And I accidentally made a dam in this situation, but if I take that dam away, everything's going to flow back downstream again. But you're going to see there's a pretty constant flow of sediment from that head cut that's continuing to be taken down with the stream, the heavy flows. Again, that's kind of acting like a fire hose. So anyone downstream from a dredging area is going to be in a lot of trouble. So we'd never suggest dredging a stream because they're not a static system, because they're going to adjust. And in most cases, they're not going to adjust in ways that we would prefer them to. There's some better solutions to those, and also more cost-effective solutions and requires less permitting, are these type of structures. So we can easily remove hazardous debris in a floodplain, depending if you need to get in a stream physically or not. That may or may not require a permit. Other things we can do, I've mentioned a whole bunch of the time, floodplain restoration, wetland preservation is huge to help prevent excess stormwater from getting into our streams. We can use habitat structures that also serve as stabilization structures that you see in those photos there. And also sometimes we have undersized bridges and culverts that could also be improved. But bank stabilization is what I wanted to focus the most on in this slide. You can see there's a whole bunch of different structures that are available to us and that we use in our designs when we do projects here at the district. You can use log materials or rock materials for these structures. We always prefer to use logs. They're cheaper, they're easier to haul, and they're definitely not nearly as expensive and heavy to deal with, and they are a little more stable also overall. So I'm just going to walk through these a little bit because I feel like everyone might be a little interested in what we can do in these streams and give you these visuals. We'll start at the top left. Those logs that are going across the stream there, those are grade control structures. So kind of like I talked to you guys earlier about slope, we can help the stream stabilize its slope by going in and designing these grade control features that the logs go across the stream, and it helps direct the flows in the directions that we want, depending on how we angle those logs in the stream bed. To the right of that, you can see some log deflectors. So those are actually facing upstream in the photo. So it's a little not how you would picture which direction you would set those deflectors in the stream. We do that because water always hits a surface at 90 degrees. So we play off of that fact when we design these. So we can really direct water flows as needed by positioning these logs in the stream accordingly. In the middle, on the bottom, or in the middle left photo, that's called a mudsill that you see. That is a log structure, protects the bank. You're not going to get nearly as much erosion. And then it looks like they also graded the bank back just a little bit to allow that water, as it fills up to get back onto the floodplain as opposed to eroding it away. We also have cross veins that you can see that they act very similar to grade control structures, and they do serve as grade control. You can create a plunge pool with that, and it's great habitat. And it also, that thalweg that I showed you earlier, that really is directing the thalweg right in the center of the stream. And so that's keeping all the pressure off the sides. Of course, riprap is something most of us are familiar with. So that's similar to a mudsill. However, it's just big rocks. They work just as fine. However, if you do get really, really high flows, there's a chance that those are going to move over time. And in most cases, they do. The bottom right, there's a rock cross vein, which acts just like a log cross vein, but you can do it with both materials. There's sawtooth deflectors, which kind of function. They're rocks, but we can kind of point them like we do with those log deflectors. And then there's also some other, bioengineering that we can do. Live stakes is something that we can put into our stream banks, and those are basically cuttings from certain species that we can actually take cuttings from, and when you put them in the ground, they'll actually start forming roots again, and so it's actually a free source of trees that you can go out, if you can identify them in the wild, cut them, put them on your stream banks, and they'll regrow. So we can get a little bit more into that later in the presentation as well. And then finally, so we have a couple other structures and things that we can do in the landscape. These are the cheapest options, and you don't need, in most of these cases, a permit at all. These are things that any one of us can do, and I highly encourage us all to consider these options. The number one thing that we could do on our streams is to reforest those streams and get more vegetation on them. So planting a riparian buffer like you see in those bottom photos there is going to help stabilize our streams. And not only that, but it helps with aesthetic value. It helps with wildlife, and we can put these on farm fields. We can put these in our streams, in our communities. It is just overall going to create a better habitat, better area, more stabilization, and better water quality. But we can also, if you're on an agricultural land, we can exclude livestock from fencing. That's another huge thing, not only keeping those livestock out of the stream, for health purposes, but you can see, up in that top right photo, if those cows had access to the stream, like that's really going to affect the stream banks themselves, and make that a really unstable system. So, having fencing to exclude them is extremely important. And we can also, and we build in, you can create access areas. So those cows will be able to walk up to a stream in a certain area and drink the water that they need, but not necessarily have access to the entire stream. So that's important as well. Other things we can do in our own houses, we can put rain gardens or increase our tree canopy throughout the landscape, as well as improving our soil. I keep talking about how important it is to infiltrate water into the soil. You can do that in your own backyard. If you have an area that is not very well trafficked, maybe you can create a no-mow zone, or create a garden or something where we can really work that soil a little more aerated and give it more pore space in order to filter in some water, and keep it out of our streams. So before I finish up here, I just wanted to walk you guys through a typical stream project. We did this project actually last fall. This is out in the Briar Creek watershed, and we did this through a partnership with the North Central Pennsylvania Conservancy. Fish and Boat and DEP were also both involved in this. Fish and Boat did the design. And you can see that it's a fairly simple design based off of those structures that I had just showed you. So I'm going to walk you through this project a little bit more in depth. So this is the area before we got started. So the landowner was mostly concerned that the stream was moving pretty rapidly throughout the landscape, especially after these high energy precipitation events. And he was also concerned, if you've noticed on that picture all the way on the right, PennDOT actually had a pole in, and it was originally not in the stream, but it ended up in the stream as it migrated. So we had a PennDOT pole right in the middle of the stream, and it also, on the other side, that bank is a roadway. So it was kind of a hazard as well. So we were dealing with that. And he also had a horse, you see in that top left photo there, that had unlimited access to the stream as well. So you can see all those banks really slumping in, minimal vegetation, poor aquatic habitat, definitely a lot of work to be done. So we went in and did the design that I had shown you earlier. And this is what it looked like during the construction. So something that's important to note, we always try to keep our equipment out of the stream as much as possible. We're as minimally as invasive as we can with the stream. It actually only takes about 2-3 people to complete these projects, plus an excavator. And it only took us 2 days of labor to complete, plus the additional day to put the fencing in. So we put in a whole bunch of different log structures, and we graded those banks back, reseeded the site, and got that fencing in. So this is what it looked like afterwards. You can see all those banks are graded. Those log structures end up really getting buried and hidden, so you don't actually really see them after the completed project is done. However, when this project was finished, just a few weeks later, we had it's our first major rainstorm since the project. It was actually a 2-inch rainstorm, so a pretty decent event. And I ended up going out and actually taking a video, and I'm really proud to say that these structures held up really well. And you're going to notice in these videos that, the water is not being concentrated in an area, it's not eroding anywhere, and it certainly has access to the floodplain, and it stays within its banks, which is extremely important. So you're going to see that in these videos here. This is the top part of that watershed. And you can see that staying within the bank, it has access to the floodplain, and it's even coming out of a pipe, and that pipe is not, it's not overfilled or anything. It's certainly handling that. Here's the video of it going around the bend and everything. It doesn't even have to jump the banks. It just stays where it needs to. And this is a 2-inch rainstorm, and we didn't have any erosion. Something else I think is important to note, if you see this, the top right photo here where we ended over by this pipe, everything upstream was coming downstream. We had sediment and it was a little muddy. And pretty much right after that pipe is where the project began. And this bottom image video down here is just below that area. And you can see the difference in water quality just between those two sites within what, like maybe 100, 200 feet. Those log structures were able to collect all that excess sediment. And something else that was really exciting as we were doing the project, we actually found a couple of trout in that stream. So we know they're using those habitat structures. We can also visually see that the sediment has been reduced and the stream has been stabilized. So it was a very successful project. And that's just one example of some things that we can do in our streams with these structures and using these principles that we talked about today. I just wanted to throw this up here in case you guys are interested in looking more into restoration through, DEP and projects like what we do. That project I just showed you is through the North Central Pennsylvania Conservancy, and so is this project as well. I will have these slides available on our website so you can see the link and get access to it. But this is another really great example of, a beginning to end example of a restoration of a watershed as well, if you guys want to check that out. So just really quickly, I just wanted to talk. There are some other important features of a stream to mention. I'm not going to get in depth with them at all today. Woody debris, it is important to note that it does have a place within a stream. I know that locally around here, it becomes an issue as we create dams and build up piles, that reroute streams. That certainly is not what we're looking for. However, if you have a small stream and you have maybe like a tree or two fall into it, those are really, really critical areas for habitat and adding organic matter into the stream. It's really important for the stream ecosystem. So don't knock the wood quite yet, but that does have a place within the stream, which is important. Another thing to note is aquatic life. I mean, we could do a whole webinar on that, just alone. But like I mentioned earlier, brook trout especially, but trout and macroinvertebrates in our streams are really, really good indicators of how the water quality is in a stream. If they're present, then that's a pretty good sign. And if they're not present, then that's worth investigating a little bit more. And I always like to also mention that, recreational opportunities are huge. And we're so blessed here in Pennsylvania to have so many great aquatic locations to explore. Kayaking, fishing, swimming, we definitely like to use our streams and value them for those reasons. And there's also economic values to, Pennsylvania has some really great trout streams. So, we have a lot of fishing license sales and tourism that comes into Pennsylvania. A lot of people even here in Columbia County buy cabins by streams because we just love being around them. And also cannot not mention drinking water supply. So, thinking about our streams in terms of health, but also, this is our source of drinking water in a lot of situations. So these are really, really important features that I think it's worth understanding a little bit more about because they do impact so much of our everyday lives. So before I finish up, I just want to send a couple of announcements out. If you guys are interested in planting any native plants or trees, to put along your stream banks or throughout your properties, the Conservation District is having our annual plant sale. Orders are due on March 12th, and you can go ahead and place your order on our website. It is right there. We also just last year started up what's called the Better Backyards certification program. So that is actually something that we can do to work with you on, and we can go out and help you actually improve your backyard in terms of its ecological function. And we can also get you a certification and a yard sign and everything. So if you guys are interested in that, definitely check out the website and it walks you through everything. You can give me a call and I'd be happy to chat with you as well about that. If you guys are interested in water quality or getting involved in some of these projects to improve streams, I highly encourage you guys to check out your local watershed association. Hopefully you guys all know now where your watershed, what watershed you're located within is. So these guys all have websites, and their links are on our website as well. But check out your local watershed association, maybe join a meeting or two just to see what they're about. They're always recruiting new members, and definitely they're happy to get you involved and see what we can do to improve our streams. And last but not least, we would love to hear some of your input about our streams. If you go on our website, we're currently working on a county action plan, and there is a survey on our website that you can give us some of your feedback and input, what you're seeing in streams around here, what your concerns are, what solutions you'd like to see happen. Those inputs we'll be able to consider and put into the county action plan for water quality. Another announcement, stay tuned. In the spring, we're actually going to have a live stake webinar and workshop. So we're going to teach you guys how to identify and cut those live stakes, how to plant them and grow them so that we can stabilize our stream banks. These are completely free. You just have to be able to identify what species of tree they are, and we will have that workshop available. Hopefully it'll be announced for registration within the next week or two. Likewise, the Briar Creek Watershed Association is going to be having a webinar similar to this one next Wednesday on the 24th. They're going to be talking about solutions to flooding in Briar Creek Watershed. So I highly recommend you guys check that out. Again, just go to our Conservation District website and you can register for the Zoom link there. I'm just going to throw my contact information up there. So if you guys have any interest in getting with me, if you guys want to talk about your streams on your property, any concerns that you have, or if you have any questions after this webinar, feel free to shoot me an email, give me a call, or just call the Conservation District to see what resource we have to help you out. We're here to help you guys and give you technical assistance and walk you through permitting processes or site design. So definitely reach out if you guys have any questions about your streams or any conservation project that you have. So with that, I'm going to open it up for questions if you guys have any. I'm just gonna, if you have a question, if you could just put that in the chat box, that would be great. And I will go down all the questions and answer them accordingly. And just for your reference, some photos on the screen there. These are all taken in Columbia County, just, as I walk around. I love our streams, so I'm always taking photos of them. And you can see, we just have some really, really great resources, really awesome streams in this area. Definitely worth thinking about and protecting. So let's see here. Let's see what questions we have. Great. So I'm not seeing any questions yet, but by all means, feel free to throw them in the chat for me. Hopefully, I hope you guys, sounds like you guys got a lot out of this presentation. I don't think I mentioned it. I did record the presentation. I'm going to have this up hopefully within the next hour or two. It's going to be on our website, right where you registered, under the workshops tab. So you'll be able to rewatch this, share it with your friends and families, please. And I'm also going to have the slides available as well. So you can watch those videos as needed if you need again as well. So Paul asked, what do you see as the main focus of study for the recently advertised Fishing Creek watershed evaluation? I think there are a lot of areas to focus on for the Fishing Creek watershed area. In my opinion, and also I know the state is pushing really hard for riparian buffers. There's a lot of money and resources out there currently to get trees in the ground, shrubs in the ground, to improve our stream banks and get some rooted vegetation in there. And that also helps with water quality a ton. So if I had to put my opinion in, my 2 cents in, I think a huge focus for improving our streams in Fishing Creek and all streams, honestly, throughout the state, I think that, adding additional riparian buffer and vegetation would be huge for the health of our stream, and also, stabilizing those streams and reducing, flooding down the line as well. Yeah, Melissa Matthews said she has been working with their township ordinances to establish buffers for streams, for native plantings and buffers. That is something else, that's another thing that we could do for sure in all of our townships, is looking at our ordinances and maybe adjusting those outdated ordinances so that we can work within our landscape a little better, especially because, knowing that what we do on the land affects the stream. I think that would be extremely important and valuable if we can reassess some of our municipal ordinances, for sure. Harold asked what the health of Nescopet Creek is. In all honesty, I don't work with Nescopet Creek too much, but they do have, I think Nescopet State Park has a bunch of resources. There are some parts of Nescopet Creek that I've been to, and you can see that photo there. That's actually relatively close to the main building at Nescopet State Park. There are some areas like that photo there that are just some of the most beautiful streams that you've ever seen. There are definitely brook trout in those streams, heavily forested, tons of hemlocks. My husband in that photo there, he's always looking for salamanders and stuff like that. So Nescopet Creek certainly has some really, really great resources. However, I do think the main branch in certain aspects have some abandoned mine drainage issues. So abandoned mines are basically mines that, we've used in the past and they've since been abandoned. But of course, the geology that has been exposed there still, affects the streams to this day. So unfortunately, we have 2 acidic streams that can't support aquatic life. But there are some areas in Nescopet Creek that certainly are very healthy. Paul asked, what's the status of the hemlock tree situation? You don't hear much about it anymore. Yeah, hemlocks, they have the hemlock woolly adelgid, which is kind of like a fungal pathogen. You definitely see it around here. Some hemlocks are a little more resistant than others. At least I've noticed some communities have them, and then some other communities don't have it. It's definitely contributing to a lot of hemlock die-off. And regeneration of hemlocks is a very slow process. So that's going to have some really, really lasting impacts to these streams and current impacts. Hemlocks are crucial for a lot of trout species and animals and critters that live in the aquatic way because they regulate temperature so well. So losing our hemlocks is not a good thing by all means. I think a lot of the focus has kind of switched from hemlocks over to the ash tree situation. We just have a ton more and more pests just keep coming along affecting our forests. But it's really important, for the resiliency of our forests to keep, stewarding them and planting native trees and plants and things like that to help, mitigate pests and reduce diseases and whatnot. Someone asked if there's any way to remove knotweed in place with native species. I wish there was. We are working very hard at Coker Park to figure out how to deal with the knotweed issue. However, the biggest issue with knotweed is that it's actually a rhizomous plant. So the root systems below the ground are extremely extensive, and they will just pop right back up. If you cut the stalk above ground, that's not going to affect what's going down underneath the soil. Unfortunately, in most cases, what you would need in that situation is a systemic herbicide, so something that would actually get into the root systems. And most of the times that involves some more toxic chemicals and that kind of stuff. So it's a little controversial to use those so close to a stream because knotweed is a riparian plant. But we are definitely looking into that kind of stuff. How to manage knotweed. Coker Park in particular is interested in actually trying goat management and getting goats in there to eat them. So hopefully I'll have a better answer for you at some point, Eric, about knotweed. Yeah, Mary Jo also mentioned not only is there the adelgid, but there's also the hemlock scale. So there's actually 2 invasive species that are affecting hemlock. So yeah, not a good situation to be thinking about. There's lots of pests for trees that are going to affect, our forests and habitats along our streams and outside of our streams. It's quite concerning. And if you guys don't know already, we have a spotted lanternfly issue that's slowly coming up to our county. They're currently in the southern end of our county. But again, that's another invasive pest that's really going to impact a lot of our hardwoods and also agricultural community as well. So you guys have any other questions? I have just 1 minute left here, but I appreciate you guys all coming out, especially on this beautiful snowy day. I hope you guys enjoyed, the talk and learned a bunch. Again, here's my contact information. If you guys ever do have any questions and want to reach out, I'm happy to talk to you guys about streams or any conservation topic by all means. So it is 1 o'clock. So at this point, I think we're going to say sayonara. I hope you guys had a good time. I hope you have a great weekend. Enjoy the sunny weather we're supposed to be having, hopefully, even though it'll be cold. And I hope you guys have a great day.